Okay, this is USNCO Locals 2024, question 1. And it says, how many moles of ions are in 75 milliliters of a 1.2 molar aqueous solution of sodium sulfate? So sodium sulfate is Na2SO4, because SO4 has a charge of 2 minus, and Na has one singular Na has a charge of 1 plus. So 2 would have a total ion charge of 2 plus. So these cancel out. So we have 1.2 molar of this much. That basically means that we have 1.2 moles of Na2SO4 per liter. So for every 1 liter, we have 1.2 moles of Na2SO4. Okay, and then we have 75 milliliters, right? So we need to find how many moles of Na2SO4 we have per liter, okay, or per 75 milliliters, and then we can turn it into moles of ions. So we have to change this into liters because we're dealing with different units. So we multiply it by 0.001 because this is milliliters, and we get 0.075 liters. So now we can complete the conversion, and we have 1.2 moles of Na2SO4 for every 1 liter times 0.075 liters. And this is going to be on the numerator, so we can cancel out to liters. So we end up with 0.090 moles. And now we have to find the moles of ions, right? So I pointed out over here, but if we just pretend that we're dissociating this turned into 2 moles of Na plus and 1 mole of SO4 minus, okay? So these are the ions, and let's pretend that there's a 1 here, because there really is. There's going to be a total of 3 moles of ions. Okay. So now we're just going to find how many moles of ions we really have in this aqueous solution. And to do that, simply, we just multiply 0.09 moles times 3, because that's how many moles of ions we have. That's going to be equal to 0.270 moles, right? And that's how many moles of ions we have in 75 milliliters of a 1.2 molar aqueous solution of sodium sulfate. So let's go to the next question. Okay. So when 3 grams of ammonia, which has 7.03 as its molar mass, reacts with 18 grams of hydrochloric acid in a gaseous form, what is the theoretical yield of ammonium chloride? Okay, so whenever you're getting like a problem with something being yielded and you have reactant to products, you just want to write out the equation. So we now have NH3 plus HCl is going to form NH4 Cl and gas solid. So is this balanced? Yeah, it's actually already balanced, so we don't even need to worry about that. So when we look at this, there's a 1-to-1 ratio, right? Or 1-to-1-to-1 ratio. And because of that, we know that however amount of moles we're going to have in one, that's going to have the same amount of moles to the product, okay? But at the same time, we're looking at the theoretical yields, so there's going to be a limiting reactant in the amount of grams we have. So we have to find the limiting reactant. To do that, we're just going to look at the moles of NH3, subsequently the moles of HCl. So we have 3 grams of NH3. And we're going to divide that by 17.03 grams per mole. So mole is going to be in the denominator, and grams are going to be numerator, so the grams and grams cancel out, right? Or grams are going to technically be in the denominator, but that's how I look at it. 17.3 grams per mole. And grams are going to cancel. So we have 0.176 moles of NH3. Next, we're looking at moles of hydrochloric acid. So we have 18 grams. Yeah, 18 grams here of HCl. And we have 36.46 grams per mole. So that's going to be equal to 0.494 moles of HCl. And it's pretty obvious that NH3 is going to be our limiting reactant. Okay. Is a reactant. Okay. Now that we know what the limiting reactant is, we know that these are in a 1:1:1 mole ratio, okay? And since NH3 is our limiting reactant, that means that NH4Cl is also going to be formed as these many moles, okay? 0.176 moles. That's because no matter how many moles of HCl we have, in this case 0.494 moles, it's always going to be limited by these many moles of NH3, because you can't just form more NH3 than we have. Okay. So since we have this many moles of the limiting reactant, that's how many moles of NH4Cl is going to be produced. So there's going to be 0.176 moles of NH4Cl as well. Okay, let's give me some more space. So now that we have that, we need to find, literally, how many grams of NH4Cl we have. So to do that, we know that the molar mass of NH4Cl is going to be equal to nitrogen, which is 14.01 grams, plus 4 times 1.01, and then there's chlorine, plus 35.45. You can refer to these on the periodic table, but I don't feel like doing it. So 53.49 grams per mole. That's going to be our molar mass of NH4Cl. We're not done. So now what we do, since we have these many moles of NH4Cl, we're going to multiply that by the grams per mole to find the total amount of grams. Let me just write this thing here. 53.49 grams per mole. So that's how many grams we have per 1 mole, multiplied by 0.176 volts. And in total, that's going to give us 9.42 grams of NH4Cl. That's the final answer. That is going to be